Hey guys, it's Rational Numbers. So our objectives are to do the following: define rational numbers, define terminating and repeating decimals, and be able to convert, compare, and order rational numbers. So let's talk about numbers. Rational numbers are just one category of a number. So you can put numbers in categories like you can most things. When you are very young, you first learn about natural numbers, right? Things you can count: 1, 2, 3, 4. Then when you get a little older, we include that number 0, and those are the whole numbers: 0, 1, 2, 3, 4. And those are the numbers you work with most of the time up until maybe like 5th grade, 6th grade. Then you start getting into negatives. And you learn about the integers, like we covered last chapter. Integers are all the whole numbers and their opposites. It's like -2, -1, 0, 1, 2, etc. Now we're going to talk about rational numbers. Rational numbers include all of the above. So it includes natural numbers, whole numbers, it includes all the integers, plus it includes every number that has a fractional part or a decimal part. That word rational comes from the word ratio. So a rational number is every number that can be written as a fraction, where a and b are integers, and the only rule is b cannot be 0. If you remember from a lesson or two ago, we talked about how you cannot divide by 0. That is undefined. And any number that is undefined is not a rational number. So the rule for a rational number, it has to be written as a fraction, a over b, and the b, the denominator, cannot be 0. So here's just another visual to kind of like show you how these numbers kind of nest. So the rational number, like we said, is a number that can be written as a over b, where a and b are integers and b is not equal to 0. So the largest group we're learning about right now is the rational numbers. A subset of that are the integers, all of the whole numbers, 0, and their opposites. And then within integers are all of the whole numbers, 0 and all of the positive numbers. Let's talk about some common fraction decimal equivalents. These are not things you necessarily need to memorize, but you're going to be at a greater advantage if you have most of these committed to memory. The fraction 1/2 is equivalent to 0.5. The fraction 1/4 is equivalent to 0.25 or 25 hundredths. The fraction 3/4 is equal to 0.75 or 75 hundredths. The fraction 1/3 is equal to 0.3 repeating. This little bar up here, this indicates that this fraction repeats. So really, this 3 continues forever. But of course, it doesn't make sense to write it that way. So what we do is we put the little bar on top. Occasionally, you might see this, where they put a little ellipsis, those 3 dots at the end. That also means that the number continues. 2/3 is equivalent to 0.6 repeating. 1/5 is equivalent to 2/10. 2/5 is equivalent to 4/10. 1/6 is equivalent to 0.16, and only the 6 repeats. And you can tell because they put the bar only over the 6. When you have a repeating decimal, every digit that the bar covers repeats. 1/8 is 0.125 or 125 thousandths, and 1/10 is 0.1. So those are some good common fraction to decimal equivalents to memorize. So let's talk about how we write rational numbers as decimals. So let's convert some fractions to decimals. We're going to start with the rational number -2 1/4. This is a mixed number. In order to convert it to a decimal, we're going to want to divide. And if you remember, I've told you that every fraction is a division problem. So I want to change this mixed number into an improper fraction. I do that by finding out how many fourths are in 2. There are 8 fourths in 2. I add that to the fraction part that is there, 1/4, and I get -9 fourths. That is the problem, 9 divided by 4. So I set that up with my dividend in the box, the divisor outside the box. 4 goes into 9 2 times. I multiply and I get an 8. 9 minus 8 is 1. And I'm going to add some zeros and bring that down. Now I have a 10. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. I bring down another 0. And 4 goes into 25 times. 5 times 4 is 20. And I get to a 0. When you get to a 0, what that indicates is that the decimal that you found, that decimal equivalent, is what we call a terminating decimal. Terminating means that the decimal stops. Every time you are dividing, doing a long division problem with the decimal part, and you get to a 0, that tells you that that is a terminating decimal. And since we're dividing a negative by a positive, my quotient, rather, I almost said product, my quotient is also negative. So negative 2 1/4 equals negative 2.25. Now in this problem, I have 5 11ths, which means 5 divided by 11. 11 is a divisor that goes on the outside. 5 is a dividend that goes on the inside. Place a decimal point after the 5 and add some zeros. 11 goes into 50 4 times. 4 times 11 is 44. I subtract and I get a 6. I bring down a 0 and I get 60. 11 goes into 60 5 times. 5 times 11 is 55. I subtract and I get a 5. Then I bring down another 0, which gives me 50. 11 goes into 54 times. And I think you kind of see where we're going. What's going to happen is that this is going to keep repeating. The 4 and the 5 are going to continue to infinity. So once you realize that, oh, I'm stuck in a repeating pattern, you can stop. In this fraction, when it's converted to a decimal, I have two digits that repeat, the 4 and the 5. So the bar goes over both repeating digits. All right, let's do one example. Let's do negative 6/5, which is the same as negative 6 divided by 5. So that means 6 is my dividend that goes in the box. 5 is my divisor that goes outside. Then you want to ask yourself, how many times does 5 go into 6? It goes in 1 time. 1 times 5 is 5. I subtract and I get 1. I'm going to add a decimal point after my 6, and I'm also going to bring that decimal point up into my quotient. I'm going to add a 0, bring that 0 down. 5 goes into 10 2 times. 2 times 5 is 10. I subtract, I get 0. That means that this is a terminating decimal. So negative 6/5 is equal to the decimal negative 1.2. Next, let's look at how we turn decimals into fractions. This is actually a little bit easier. Not a whole lot of division involved here, unless you're simplifying. So here I have the decimal negative 26 hundredths. What you do is you look at the last place value. You need to think about what you said. You said negative 26 hundredths. The place value is the denominator of the fraction. So the digits after the decimal point become the numerator, and the last digit, that place value, becomes the denominator. So I have negative 26 over 100. This can be simplified because both 26 and 100 are divisible by 2. So you divide both by 2 and you get negative 13/50ths. All right, let's look at converting some decimals to fractions. Let's look at number 5. I have negative, let's pick my pencil here, negative 0.7. What that is equal to is negative 7 tenths. So all the digits after the decimal become a numerator, and the place value becomes the denominator. The place value is tenths, so that goes over 10. And since this is a negative, my fraction is also a negative. So negative 0.7 is equal to negative 7 tenths. All right, so the trickiest thing we're going to do in 2.1 is ordering these rational numbers on a number line. And it's tricky because you're going to be given a variety of numbers, fractions and decimals, and you're going to have to convert some of them. The easiest way to do these is to convert all the numbers to decimals, but I'm going to teach you both ways. How to convert all of them to fractions and put them in order, and also how to convert all of them to decimals and put them in order. So I'm just going to go through one example here, but the actual practice we're going to do together in class. So this table shows the elevations of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale, and explain. So they give us the anglerfish, which has an elevation of negative 13 tenths, squid, negative 2 1/5, shark, negative 2 11ths, and the whale is negative 8 tenths. I need to figure out which one of these creatures is, or which could be more than one, which one of these creatures or more are lower or deeper than the whale. So the whale I can put on my number line pretty easily. And what I need to do is convert each one of these fractions into their decimal equivalent. Negative 13 over 10 turns into negative 1.3. Negative 2 1/5 is equal to negative 2.2. And negative 2/11 is equal to negative 0.18 with the 1/8 repeating. Then we place each value on the number line. The squid is farthest to the left down here at negative 2 2/10. The anglerfish is next at negative 1 3/10. And the greatest value is the shark at negative 1800ths repeating. So both negative 2.2 and negative 1.3 are less than the whale's value at negative 8/10. So therefore, the squid and the anglerfish are both deeper than the whale. All right, next time we are in class, we are going to start focusing on these rational numbers. We're going to practice converting them and putting them in order. So get ready. I bet you thought I was going to tell you why I'm dressed like this.